Right, so now we're going to look at this grill cover. You can see the 3D image of it here. We've got dimensions 208 overall by 108 overall. We've got 9 slots, 68 centers, 6 radius, 28 from the edge, 19mm spacing, and we've got some holes inside that go through both sides there. You can see we've got 2mm 304 stainless. So let's go to Inventor, open a new file, new part, and we'll go for a sheet metal IPT. And we'll go over here, start sketch. I'm going to select the XY plane, go up here to rectangle. I'm going to change this to 2-point center. It's easier to constrain this one, so I could just drop the center and the origin point there. I can go 208, press tab, 108, enter, close this box, finish sketch. I'm going to double click on my middle mouse button to zoom out to it. Next thing I'm going to do is I'm going to set up the material and the thickness of it. So I'll go sheet metal defaults here, and I'll untick this thickness from rule. I'm going to go to 2mm here, and you see it's got a K factor and the sheet metal rules generic. I'm just leaving that because it's pretty good as it is. And let's change the material, so we'll go up to this bar here, generic stainless steel. So that's going to change the appearance slightly, and that's going to help calculate the weights properly. So let's create a face, and you can see I've hovered over it and it's picked up, there's a profile there, a closed loop. So it's going to know that this is where it's going to go. A few options to be aware of here is we've got different directions. So if I zoom into this corner here, it's going to project out the other way of that drawing, or forward, backwards, or the drawing is going to be in the middle of it. So that can be handy in different circumstances. But for now, I'm just going to go to the default one and apply. Next thing we do is we're going to go to flange. Two options here initially. So we've got singular edges or loop select mode. So this one's handy if you just want the flange on a couple edges, or you want different angled flanges on either side, or different lengths. So this one's the same all the way around, so I'm just going to select a loop and click that face there. You can see they've all come out, and the default setting is 25, which is what I want anyway. So you've got a few options here, distance or 2, so if there's another part further away, you could tell it to go to that part, or if there's another plane further away, you could tell it to go to that plane as well. Bend positions, so the main two that I use, you've got inside of reference plane and outside of reference plane. So if I wanted this to be 208 by 108 inside, so to fit over something 208 by 108, I would go to this one. You see it makes it a bit bigger, but I want it to fit within those dimensions, so I'm going to go inside, like that. There's a couple other ones I don't use too often, but just be aware they are there. And here as well, we've got some options. So from intersection of two outer faces, this is generally the one I use the most. What that is going to do is that 25mm is going to be from the top of that part to the edge here, so it's going to be 25mm overall. You have different options here that can go from the inside or from different points, which I don't use particularly often. So let's just go apply on that, close. Now I've got my base part, and hold shift and zoom around, have a look at it. Next thing I like to do once I've got my parts sorted is I'm going to set up my home view. So currently home is going to this view here, which isn't what I want to see. I want to go on this view cube here and I'll click around top and maybe that corner there, or turn it around a bit. So that's really what I want to see when I open the file up, and it also saves this view for putting on your drawing sheet. So once you've got it in position that you want it, doesn't necessarily have to be any of these positions on the view cube here. You can rotate it to any position you like. You come up to this home and right click it, set current view as home, and go fit to view, which is going to mean when I double click this mouse button, it's going to fill up the screen with the part. And if you notice this view cube here as well, so this is currently the back of the part. I don't want that to be the back. To me, that's the top. So I'm going to right click on this view cube, set current view as top. So now that's the top. And you see my home position stays the same. So this is now the top of it, which is what I wanted it to be. Right, so now it's time to put some slots in here. So we'll have a look at the drawing again. So we've got 9 slots. We've got a measurement of 28, 68 centers, and 6mm radius there. So now I'm going to start a sketch and click on this face. And I'm going to rotate this around the way that works for me in my head. I'm going to go to construction line. So construction line will help me place my drawing, but it won't affect the drawing, as in when I go to cut the holes and that'll be ignored by the feature. So you can see I've got a line that's going straight up and down like this. Now what I want to do is center it this way about the origin point. So now I'm going to center this about this origin point here. So I want it to be the middle of this line to be in line with this point. So I'm going to go to this vertical constraint here. I'm going to hover over this part until we've got a nice green dot in the middle, and then click this part here. So that's going to bring that down. So now that's in line with that origin point. So we're always keeping things about the origin point. Press escape to get out of the function. Now you can see what I do. I've got this line here. Now if I stretch this end point, this little green dot, you can see it grows and even flips around that point. It can move anywhere along here. And if you check it out here as well, it's got 2 dimensions needed. So if I go dimension, and I want to go from this center to this edge, hover over the very far edge there. Always be careful when you're dimensioning off geometry, because it can sometimes pick up on, say, points like that, the edge here. So make sure you zoom in nice and close if you need to. And that was 28mm from the edge. Now let's dimension the actual length of it. So these were 68mm centers. 68. Now we can turn this construction line off. Important thing to know is if you accidentally leave that on, it'll keep coming out of construction lines, but you can change them. Say I accidentally made this construction line when I want it to be an outline. I can click on that and then I can unconstruction line it like that. You see it's a solid line now, but I do want that as construction, so I'm going to put that back on. Now, got my construction line off. I'm going to draw a circle here, hover over the end of that line. It was 6mm radius, so it's 12mm diameter. And it's 12mm diameter down here. I'm going to go to a line function, and I'm going to hover over the side of it, and it's going to try to cling to the side of the circle there. You can see it's got that wee tiny tangent symbol next to it. And I'm going to go over here and do the same on this side, like that. Escape to get out of the function. Now you can see still got one dimension needed, but we also need to trim out the inside of these circles. So let's just go to trim. Now sometimes when you're trimming, it can lose some constraints or dimensions, so that you might actually end up with more things needing to be fixed down here. There we go. So it still needs one dimension. So what's a good idea to do is, if you don't know what it needs, you can come up here to automatic dimension constraints, and it says one dimension required. Let's go apply. And what it's done is it's done a tangent constraint up here. So it didn't quite know that this was connected to a tangent there. So that's good. So now we've got our slot drawn out. Let's go to finish sketch. Let's go to cut. So this is only a function that's here when you're in sheet metal mode. So it's picked up that loop, that closed loop that hasn't had anything done to it yet. So it's also picked up the idea that it's got to cut through the metal like this. There are different options here. You can cut through multiple pieces at once, as long as they're in the line of where this would go. You can cut to a certain depth, you can cut to another plane or another edge, but I'm just going to leave it as cutting the thickness. Go OK. And you see we've got our slot cut here. So now we've got our slot, what we need to do is create an array of it. So let's go to rectangular. We're going to make a pattern or array of that part coming along. So I'll just highlight that edge there. And direction. So direction, you can use edges or faces. So if you use a face, it's going to go perpendicular to the face. If you use an edge, it's going to go parallel to the edge. So I'm going to use an edge. You can see the arrow is going that way. So it's trying to put the pattern off the other side, which is not what I want. So I'm going to do this little bit here, flip, and it's going to come this way. I'm going to tell it I want 9 of these. You can see it's projecting where they're going to be, and the part spacing was 19 mil center to center. So there, we type that spacing in and go. Okay, so now we've got all our slots on here. The next thing we're going to do is we're going to look at there was some screw holes on this. So I'm going to bring that back up. We've got them 10.5 from the edge, 10.5 from the base, 23.4 from the edge, 5 mil diameter holes. So let's grab this drawing up again. I'm going to start a sketch on this part here. And I'm just going to put the circle, drop a circle there. I'm not going to give it a size, and drop a circle there. So now we've got these two circles here. First thing I'm going to do is make sure they're equal. So these sizes here will be the same. Then I'm going to make sure they align horizontally. So let's go to horizontal constraint and click here and here, center points. Now look, see what it's done here. They've aligned vertically. So if I grab one of these points, they've aligned this way. So what happens, depending on what you've used, like sometimes this can actually be round the other way. So you can see it's got a Y here and a Z here. So that's a vertical constraint that we need. So all you do is, if it's done it the wrong way round, you just go Control Z, Z, back to where you were, pick up the other type of constraint, and that's what we wanted. Now, let's do a dimension. These are 5mm holes. 5. This dimension from the edge was 23.4. Click the center point, click the edge here, 23.4. I'll do the same to this one. I can also do this. I can go equals that one if it's the same dimension, and then this one will change that one, or it'll be equal. You can actually add equations into the dimensions, so if you can't figure out in your head, say it was certain length in from the side, you can add in, you could say something or other, divide by 2 if it's like a radius, for example. But anyway, let's get on to it. Dimension from the center point here to the bottom, and that was 10.5. Now you can see we've got fully constrained down here, everything's black, so that means it knows where it is. Let's go to finish sketch. Now what we can do is cut these holes, cut that, that. So we want them to go all the way through. We want both sides to be like that. So there's two ways we could do that. We could cut these holes and then mirror it at about the origin plane, or in this instance we can just go all. It's going to cut the holes all the way through both sides. So there we go. That's the part drawn up. So now we've got the part. What we can do is go to create a flat pattern. So the main problem people experience with this is if they haven't set their material thicknesses correct, or they've drawn like a weird radius or something where the thickness changes. As long as the part has a consistent thickness, it generally works pretty well. And as long as it isn't connected, say if this corner was joined together, it wouldn't flatten because it couldn't open it up. So we'll go create flat pattern, and there we have our flat pattern. So this is really good for figuring out your fold dimensions and things like that for like complicated brackets. You can draw profiles of things and then flatten them out, and it'll give you a good cut length, etc. So if you were just drawing something simple to find the length of it, you could go into inspect and do one edge to the other. So across this way it's 251.048. Anyway, so now we've got our flat pattern here. You can see it's generated on the side. So if you want to go back to your part, you have to go over to your flat pattern tab, you have to go back to folded part. If you change anything on your part, if you deleted a few slots or whatever, you go back to flat pattern, the flat pattern will have changed. And say if you got rid of these holes, the flat pattern will get rid of the holes. So I'm going to click on this face with the left click, right click it, and I'm going to export this face. So now we've got our flat pattern. What I'm going to do is I'm going to export this as a basic AutoCAD file. So that would be the sort of file you'd run, put maybe this thing through a plasma cutter or a laser or a turret punch. So way to do that is left click it, then right click it, export your face as. You want to find your folder that you're working in. Let's go into here. I'm going to right click, And create a folder for this grill cover so I don't get my parts confused. There we go, grill cover. Put it in, click in that again, and so there's two options here. You've got DXF or DWG. So DXF generally works better with some older machines, plasma cutters, turrets, lasers and things like that. Some of the newer machines interpret DWG a bit better. Our plasma here does DWG quite well, so I'm going to do it as a DWG. And I'm going to call this grill cover flat pattern. It's going to save our DWG file. Go back to folded part, and you can see up here it's just called part 2 at the moment, so I haven't actually saved this. So I'm going to go file, in the same folder. I'll make sure I'm in the same folder, grill cover. So now we've got the part file. I might just collapse this here, so this is all the details as you're working through it. And we'll go Control S to save it again. So when it comes up, it'll come up like that. Close out of that. Now what we want to do is we want to put it into a drawing file. So we're going to make it look like this one. So what we're going to do is we're going to open up File, New, T-Puking drawing template is what we're using at the moment. And now we have what's basically a paper space. Now, first thing we can get started on is we can actually bring in a view. So we'll go base view here. So now we're going to bring the view, the piece into our bit of paper. Let's find it. So we've got grill cover here. Open that up. And you can see it's doing projections as I hover over here. So the first thing I usually do is I'll get a nice 3D view of it, isometric view. I'll just rotate this cube around a bit, just clicking on it, and I'll get a nice 3D view like that. I'll come over here to options, so this is hidden line removed. Okay, that's good. This is shaded, so I'm going to put shaded on, and also come over here to display options, and I'll click on this tangent edges. So this will show up where your fold starts and ends, and I'll just go with that scale for now. I'll just leave it as it is, go OK. So nice isometric view in the corner. That's going to help whoever's having to make this product visualize it. As you know, sometimes drawings can be a bit confusing when you've only got the plan and the side views and that. So this is really a good practice to get into, is putting a wee 3D view of it. So say I want to make this slightly bigger because it's not as big as I want it to be on this page. So let's make it a scale of 1 to 1.5. And grab that view, just pull into the corner nicely there. That's good. So now we've got our wee isometric. Let's put the third angle projection views down. Let's go back to the same file, got our grill cover here, open, let's bring up this view cube, make sure we're looking at the top. That's the view I want to do, and let's see about the size. I think 1.5, 1 to 1.5 seems to be about a good scale for this. So I'll type that in. And you can see here we've got some things up, so it's got hidden lines on, so I don't really need hidden lines for this one. So I'm going to click over to hidden line removed. I don't want to dimension it shaded. Generally, the rule is for engineering drawings, they're black and white, bar dimensions and center lines and things like that sometimes. This shaded view here should be the only shaded view you have. And display options, I'm going to make sure that tangent edges is on again. There we go. So we've got our base view. And I'm going to put that here for now. Let's go projected view. So if you see, we bring this one down, it's going to look over it that way, over it that way, around it that way, and around it that way. So that's your third angle projection there. So I'm going to put this one down here, left click it, right click it, create. I drag this one slightly closer, and you can see they're aligned with each other. So you can actually break the alignment, but I might show you another time because it's not necessary right now. Let's do a projected view of this one. So there we go, we've got our three views. Now we just need to do our dimensions. So let's have a look at this example one I've got. So this was enough dimensions to make the part. So that's what I'll be looking at when I get your drawings. I'll be checking if there's enough dimensions that I could redraw it myself off your drawing. So let's get on to putting some dimensions. So let's look at this top view first. I'm going to go overall dimensions for a start, 208, and I'm just going to see how this box has popped up. I'm just going to put a space and I'm going to put an O/A for overall, and I'm going to do the same on this way. Put a space, OA overall, so that way it's the person making it can know that's where we're measuring it from, even though it's sort of shows on the drawing. Just important to note here, so this particular template's got dimensions, all dimensions in millimeters, so you don't have to write millimeter all the time. Unspecified tolerances, so this is just a general rule for the tolerances. So 0 is plus or minus 2, so that means if you put a dimension of 200 on there, it could be 202 or 198, anywhere in between. If you have a one decimal place there, 0.0, it could be plus or minus 0.5. So if you put 200, you could be 200.5 or 199.5 or anywhere in between those. So it does matter about these trailing zeros here. So we're going to leave them on for that part there. And now I'm going to do a bit of dimensioning of the height. So let's dimension the height. I'll put it over out the way here, 25. And I'll leave the 0.0 on there just to make sure that it's within tolerance. Now we need some center marks for these slots. So we can come over here to the center point, and I'm going to put one here, one here, one here, some over here. I don't have to put them on everything, just enough to get the detail across. So let's dimension from center to center. So when you're doing center to center dimensions off these points, if you come in real close, there's little other points in here that you want to avoid. So you want to make sure you're hitting the end of the line here. The end of the line here. That way you'll get center to center. You see where the arrow is. So we've got 68. Let's bring that outside the drawing there. Now we need to put a radius somewhere. Let's go here, we'll do. And I'm just going to drag that off here to the corner. Go OK. And now the positioning, so we had 28 from the edge, so I'm going to zoom and make sure I get that line so I don't get the wrong point. 28, and the spacing between the two is 19, so I'll drag that along and line it up with the other one, like that. Right, what other dimensions do we need? So we need to know where these holes are. So let's put some center points in there for a start. Just click on that. That will dimension from the bottom to that point there. So hover over that point, bottom line, drag that out, 10.5. Okay, let's do the same here. So point to this edge, 23.4. And same over here, but we've already got the height over there, so we don't really need it. Let's drag that down 23.4 like that. And it's always a good idea with things like hole centers and that is to put the actual distance between the two. So someone can put them 23.4 from the edge, and then they can check the centers as well, make sure that it's right. And I'm just going to drag this up a little bit so I can hover over it till there's that move symbol. And I'll line it up with that one there. So there's our hole centers dimensioned. Now we better put our hole size on there, and we'll dimension that circle 5. If you wanted, you could type TYP after that for typical. I wouldn't think it'd be too necessary for this one. So there, that should be enough dimensions for me to go ahead and redraw that or make it from scratch. Now I just want to fill out this title block. So the easiest way to do that is just to go into your text menu here, click on the top left of where you want the sketch, and it'll bring up this text box. So we've got different sizes and fonts and that, but I wouldn't worry too much about that. And scale, I've got 1 to 1.5 here. Material 2mm 304 stainless steel. Date drawn, so this auto populates here. And part, this is a Grille cover. So if you're not quite happy where those are gone, you can always make sure you just escape and hover over the middle of it, and you can drag it around and move it. I wouldn't get too fussy about that though, as long as they're in the right spot roughly. Drawn by, let's click in there, this one's drawn by me. Okay, so we've got a filled out title block. We've got all the part there, we've got a representation and isometric so that people can easily see what it is, and all the dimensions you should need to make it. So what I'm also going to do is put a flat pattern drawing in so that the person who was going to build this would know where their fold lines are and things like that, and even a fold sequence, which can be quite important with complicated shapes. Probably not so important with this one. So I'm going to name this sheet. I'm going to double click on it, double click again, and I'm going to call this Grille cover folded. Click off it, and what we can do is come up to here to place views. We could do a new sheet, so you can keep adding sheets and sheets and sheets, and this will all stay in this one big drawing file. First thing I'm going to do with this one is I'm going to name it flat pattern. Now we go back to what we were doing before. So we put base view, find the part, Grille cover here, open. So see we've got a little flat pattern option down here. So if you go to put your drawing view in and it doesn't have that, it means you haven't gone into your part file and actually created a flat pattern. So that happens quite often. People will do the drawing and then they won't remember to do the flat pattern. So you really got to make sure you do that and then save it, and it should have the part and the flat pattern in the same file. Now this one can be a bit bigger, let's say one to one, and let's just go OK. You see it's put our fold lines in there for us. So I'm going to say this has been laser cut out. The person that's making it just needs to know what to fold, where to fold it, and by how many degrees, that sort of information, and what size the pattern should be. So let's put the overall size on here, go there to there, there to there, and the fold dimension. So let's go to that fold line, and so that I would have thought would be enough dimensional information. Now I'm going to get into the habit of writing fold sequence. So for this one, it's probably not overly important, but I'm going to put it on there to be extra helpful to the person making it. And I'm going to say fold one up 90 degrees symbols on this button here. There's various other symbols as well if you drop down. Fold up 90 degrees. We could put, say, a radius in here. So let's say the radius is 2. So that will help tell them what tool they need to use on the press brake, things like that. I'll grab that, put it in about the center. Now I've got the fold information 1 on there. I'm going to click on it, right click and go copy. Then I'm going to click off to the side here, right click and go paste. And you can see it's come up again. So now I'm going to drop one here. I'm going to drop one over here and one over here. This one I'm going to go hover over it, right click and rotate 90 degrees counterclockwise. This one I'm going to come over here and do the same thing, counterclockwise will do. Position it more close to the fold there, close to the fold on this one, same with this one. So let's say fold 1, fold 2, let's do the same size, same length of fold in that order. So you'd want to do this, that one, and then you'd want to do this one and this one because they're going to be the same length. Let's change this to fold 3. Fold 4. Okay. Now that's all the information we need for folding it, marking the fold lines, etc. Let's just make sure we have the scale and all the details in here. So 1 to 1, material 2mm 304 stainless. Part, I'm just going to put in there flat pattern. Drawn by, obviously myself. So that's our 2 drawings ready to go. I'm going to go over here and save. Under my folder, I'm going to change the name to Grille cover. And this is going to save as what we call IDW, which is Inventor Drawing File. Next thing I'm going to do is go File, export PDF, same folder again. Now you want to check your options here, and by default it'll probably be on current sheet, so only save the current sheet that's open. You want to go all sheets, and or if you want to do something a bit different, you can do 1 to whatever. Just standard resolution is fine. Let's go OK, save. So now we've got the drawings all done and saved. What we want to do is we just want to go into our folder, have a look, make sure we've got a PDF, an inventor part, an IPT, an IDW, which is an inventor drawing, and your DWG. So you should have 4 files, 4 different file types of this.